All right, so let's practice together. So draw a Lewis structure for each of these compounds. Start with the acetylene C2h2. Okay, no doubt carbon is going to be in the middle, and the rest are around it. All right. Now Lewis symbol. So carbon 4 unpairs. All right. Hydrogen each 1 unpair. All right. So make non-central octet first. So for each hydrogen, just 1 bond. Carbon on the top. Well, the carbon in the middle got only 2 electrons left. You got only 2, so you should get that. Now, if you count the number of electrons total, carbon in the middle 1, 2, 3, 4, 5, 6, 7, 8. That's octet. But at the top though, 1, 2, 3, 4, 5, 6. That's not octet. What do we do? Well, we usually form more bonds. But in this case, it doesn't really help. If you want to form more bonds for this carbon, you need a lone pair from this carbon from someone else, not just use electrons on the under octet carbon. Under octet, an under octet atom is already not. It doesn't have enough electrons. You can't just go use it and you end up with 1, 2, 3, 4, 5, 6 electrons. Doesn't do anything there. Okay, so and carbon in the middle is also over octet. So it's anyway. So my point is, sometimes you encounter a structure that not everyone is happy. Now, not everyone is octet. So you have to come up with a new structure. Right. So in this case, you can do this too. Since we have 1 carbon in the middle as a central atom is not good. Why don't we use 2 carbon as a central atoms? Now take a look. Let's take a look. Okay, it's in your imagination. Now Lewis symbol. All right. For make each hydrogen octet first or stable first, 1 bond each. And now carbon from 4 bonds. You know that, right? Each carbon got 3 unpaired electrons left. Ta-da! Here we go. That's the structure of acetylene. Because the first structure is not really stable. This structure is much more stable. Everyone is octet. 1, 2, 3, 4, 5, 6, 7, 8. This carbon is octet. Carbon on the right, 1, 2, 3, 4, 5, 6, 7, 8. Everyone is happy here. Okay. Or sometimes you have to change the way you draw. So don't freak out if your first drawing is not it's something smelly. Okay. All right, next one. So Icl2 Plus. All right, so looks like iodine gonna be in the middle, and chlorine is around it. Right. Lewis symbol. So iodine, so 7 electrons. Chlorine 7 electrons. So 1 unpair each. All right. Now don't forget that there's a positive charge in here. The positive charge means remove an electron from a central atom. So remove from 1 electron from iodine. So from 7 go to 6. Okay. All right. So next one, make a non-central octet first. So each chlorine will form 1 bond each. And yep, that's what you get. Everyone is octet. You can count it. Okay. All right. Now move along to the next one. So we have H2O2. So hydrogen peroxide and BrF3. All right. Start with the H2O2. So 1 oxygen gonna be the central atom. Right. Put oxygen here, put oxygen there, and the rest are hydrogen. Now Lewis symbol. So 2 unpair each for oxygen, 1 unpair each for hydrogen. All right. Now make a non-central octet first. So start with the oxygen down here. So 2 bonds. And for hydrogen, so 1 bond each. Let's see what we got. All right. Let's check real quick if everyone's happy. So oxygen here, 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons, so it's good. So not 8, so 8 electrons total. Oxygen in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not as good, right? So in this case, the oxygen at the top have way too many electrons. What do? We adjust structure. So break some bond, right? So we're going to break double bond here. Ta-da! You get that? Now, here's the thing though. The oxygen on the top, 1, 2, 3, 4, 5, 6, 7, 8 is good. Oxygen at the bottom, 1, 2, 3, 4, 5, 6, 7, 8. It's also good. Better than the first one, right? But in the next couple videos, you're going to learn it later. This structure has charge. Right? The oxygen at the top got positive charge. The one at the bottom got a negative charge. Not so stable. This one actually not so stable. That's another way you can draw this structure and make everyone's happy and everyone is neutral. Take a look right here. So put both oxygen together and hydrogen outside. Lewis symbol, Lewis symbol. Make from one bond to hydrogen. Okay. Now, if you remember oxygen group 6, so 2 bonding capacity. This is 1 and then 2 together. That's it. That's the structure of hydrogen peroxide, and everyone is octet and everyone is neutral. Okay, so this is going to come from your experience. You have to draw enough that, and you realize that later, oh, this is not as stable. This is much more stable. Okay, so next one. So bromine trifluoride. So bromine, no doubt, there's a central atom, fluorine around it. All right. So Lewis symbol. So 1 unpair, 3 lone pairs. 1 unpair, 3 lone pairs for everyone. Make a non-central octet first, so fluorine, 1 bond each, and looks like that's it. Okay, now this one's easy. All right, so last before we go, so concept test real quick. Why do we adjust structure? Remember we talked about like sometimes you have to adjust structure, but why do we do that? Just to check that if you understand what's happening here. All right, so we adjust structure. So one, in the case that we form bond, because some of them are not octet and need more electrons. So I just call it under octet, right? So this carbon here, 1, 2, 3, 4, 5, 6. So that's why we have to form 1 bond to make this carbon octet, right? Nitrogen, 1, 2, 3, 4, 5, 6. From 1 bond to oxygen, make this nitrogen octet. Okay, that's the first case scenario. Another case, when an atom has way too many electrons, usually a central atom, right? In this case. So we have to break bond, and you can break on either side. Okay, so that's why we have to adjust structure. All right. So, and the reason why we have to adjust structure because right here, so the maximum number of electrons of an element in period 2 on the second row. So second row right here got 1 s orbital and 3 p orbital. So maximum of this level is 8 electrons. That's why carbon, nitrogen, oxygen, fluorine can have maximum of electron just 8. But if you go up to go down to the third period. The third period start having d orbitals, right? On fourth period start having d and f. On the fifth got d, f, and g. These guys can be over octet because they have orbitals that can hold more electrons, right? But not for the second period, second row element. Okay. All right, now class activity number 1. So basically just Lewis structure. That's it. We got a key right here. All right, so anyone here see the baby? Let's take a look at the key. The answer, the baby is right here. See the baby? That's a head. There's hands, arms, feet, a belly. It's pretty difficult to see. It's kind of like fool your eyes, right? All right, let's moving on.